Line coding techniques. Line coding is the process of converting digital data into digital signals. Let's see how this works. Unipolar scheme. All the signal levels in this scheme should be above or below the time axis. And when you draw the signal, you have to consider these two things. When you have bit 1, then you have to mark a positive voltage, and when you have bit 0, you have to mark 0 voltage. Let's see how to draw the signal according to this given data. Unipolar scheme. In this scheme, all the signal levels should be above or below the time axis. And you should have to remember two things. When you have bit 1, you have to mark a positive voltage, and when you have bit 0, you have to mark a 0 voltage. The data you have here is 10, 11, 0, 10. So my first bit is 1, therefore I have to mark a positive voltage. See how here I am going to start from this level of amplitude, and I have marked my bit 1 as a positive voltage. And next I have bit 0, therefore I am coming back to 0 voltage, and I am marking a 0 voltage. And here again I have to go back until 1, that means positive voltage, and for the next one again positive voltage, and for bit 0, 0 voltage, and for bit 1 again I'm going to mark a positive voltage, and for the last bit I have 0, therefore I have to mark 0 voltage. So that's how we draw unipolar scheme. Next we are going to draw polar scheme. And now in polar scheme we have two different methods, NRZL and NRZI. NRZ means non-returning 0 and NRZL means non-returning 0 level. Here we have to use two levels of amplitude. And you have to remember that when you meet bit 0 you have to stay up, and when you meet bit 1 you have to stay down. Let me draw this data signal. First, it starts from 0, that means you should have to stay up, and we do not return to 0, and when we meet bit 1 we have to go down. Here I meet bit 0 at the beginning, so I'm going to draw voltage level up, and when I meet bit 1 I'm going to go down, and again next bit I meet bit 0, that means I have to go up, and another 0 means I'm going to stay up. For bit 1 I'm going to go down, and here another 1, that means stay down, again another 1, and for the 0 I have to go up like this. Here we have another polar scheme, NRZI. NRZI means non-returning 0 inward. So for the beginning bit, I'm going to think of NRZL and draw the beginning bit. So thereafter, as the second bit, I meet 1. And this scheme, we say, when you meet bit 1, you have to make a transition. So I'm going to make a transition. That means I'm going to go down and then draw the signal like this. And now I have bit 0. In NRZI, when we meet bit 0, we do not have a transition. It means I'm going to continue my line like this. And another 0, that means continue the line. And the next bit is number 1, therefore I have to make a transition. I'm going up and draw bit 1 like this. And again I have bit 1, that means I have to make another transition. So I'm going to go down and draw the bit like this. And another one is there, so I have to go up and make the transition. And for the last bit I have 0, that means I do not have any transitions, and I'm going to draw the line continuously up to here. And now I'm going to show you another example pattern for NRZI. In this example, I'm going to draw my signal starting from lower level. So here for bit 0, I'm going to draw the line starting from lower amplitude, and when I meet 1, I'm going to make a transition. And as the next bit I meet 0, that means no transition. Again for the next bit, no transition. And for the next bit 1, I have to make a transition. And I have the other bit as 1, and then I have to make another transition. I'm going up, and for the next bit again I have to make a transition. I'm going down and roll like this, and for the last bit I have 0, that means I do not have any transitions. So when you compare the previous example and this one, you can see that the signal is inverted. So it's up to you to decide whether you are going to start from upper level or lower level. What you have to remember is when your next bit is 1, you have to make a transition, and when your next bit is 0, you do not make a transition. And next I'm going to draw bipolar scheme. Here also we meet two options, AMI and pseudo-ternary. So first of all, I'm going to talk about this AMI. So when you have AMI, you keep your amplitude at 0 level when you meet bit 0, and when you meet bit 1, you have to change your wave positive and negative. So you should have to have alternating waves for bit 1, and for bit 0 you remain at the 0 level. So here I'm going to start from 0 level, since I have 0 bit here at the starting point. So I'm going along the timeline like this, and when I have 1, I'm going to mark a positive voltage, and again when I meet 0, I'm going to come back to 0 level, and another bit 0 means remain in the 0 voltage level, and when I meet 1, I have to mark a negative voltage. Why? The first bit 1 we got there with positive voltage. So here I'm going to draw a negative voltage for the second bit 1. And for 0, I'm going to mark 0 level. And for the next bit 1, I'm going to alternate the previous signal. That means for the previous one, I mark lower voltage, and for this one, I'm going to mark higher voltage. That means positive voltage. And again for 0, I mark 0 voltage level. So when you start from the beginning, for the starting 0, I have marked 0 voltage level, and for the first bit 1, I have marked positive voltage, and here for the second bit 1, I have marked negative voltage, and again for the third bit one I have marked positive voltage. And now assume you have bit 1 here instead of bit 0. So how do you draw your signal? With AMI. So here again AMI means alternate mark inversion. That means you have to draw alternate signals for bit 1. Here when you meet bit 0 you have to stay on this 0 level. When you meet 1 you have to mark a positive voltage. I'm going to mark my voltage like this as a positive voltage. So here I meet 1, that means I have to alternate the signal. That means I'm going to mark a negative voltage. And for 0 on the 0 level, and when I meet 1 I have to alternate the previous signal which I have here as a negative voltage. So in this case I have positive voltage, and again for 0 on the line, and for 1 not as a positive voltage because here the previous one I have marked as a positive voltage. So for this one I have to mark a negative voltage, and for 0 on the line. So that's about AMI. So you have to remember when you draw signal for AMI, you have to alternate your signal each and every time you meet 1. If you have 0, you do not use positive or negative voltages. What you do is you have to mark your voltage level as 0. And now for pseudo ternary, here for bit 1 we mark 0 voltage, and for bit 0 we use alternating positive and negative voltages. So when you compare these two, AMI and pseudo ternary can be said as opposite of AMI. So here I have 0. So when I draw AMI, for 0 I marked 0 level. But since the pseudo ternary is opposite of AMI, for bit 0 I am going to draw a voltage level as a positive voltage, and for bit 1 I'm going to draw 0 voltage. And when I have bit 0 I have to mark a voltage level, but here for the previous 0 I have marked a positive voltage, and now I'm going to mark a negative voltage. And another 0 is there, therefore I'm going to mark a positive voltage because I have to alternate the pattern like this. And for 1 I'm going to mark 0, and 0 I have to alternate the signal like this, and 1, and for 0 I'm going to alternate the signal. So now the last encoding scheme, Manchester and de-Manchester. In these schemes, it includes extra transitions in the middle of the intervals. The benefit of this extra transition is it provides synchronized information. So here, when we talk about Manchester encoding, for bit 1, we have to make a transition from negative voltage to positive voltage. And for bit 0, we have to make a transition from positive voltage to negative voltage. So from negative voltage to positive voltage means something like this. So your signal should rise up. So for bit 0, positive voltage to negative voltage means something like this. Your signal rises down. So if you see these two signals here, you have this pattern like letter S. So here you have, for 0 you have a letter like Z. So simply remember, for bit 1 you have a pattern like S, and for bit 0, 0 starts from letter Z, 0 and Z. So here you have to draw a pattern like Z. So this is not an actual Z, but it's similar to that of Z. So here now I'm going to start the signal. So for the first bit I have 0, that means I have to make a transition from positive voltage to negative voltage. So here I'm going to draw like this. And for bit 1 I have to mark negative to positive voltage. That means a pattern like this. So I can't rise the signal up. I have to draw like this. And now I'm going to rise up the signal. For 0 I'm going to mark like this, like letter Z. And again for this 0 I have to mark like this, a pattern like Z. So I have to rise up the signal here. I have to start from this level, and again I'm going to mark voltage drop from positive to negative voltage. And here I have 1, that means from negative to positive, like letter S. And here I have 1, that means again I have to draw a pattern like letter S. That means I have to come down and draw the pattern like this. So when you draw, make sure that this line comes somewhere here in the middle. And for the next transition 1, again I have to drop my signal, and then I'm going to draw the pattern like this. And for 0, pattern like Z. So my signal looks like this at the end. So here if I say again for 0 I have, see, Z-like patterns here everywhere. If you check each and every place I have Z-like pattern. And for number 1, I mean for bit 1 I have a pattern like S in each case. So here you see the pattern of Manchester encoding. My signal is not that perfect, so when you draw signal you can draw it perfectly. And then let's move into the differential Manchester. And now let's see how to draw signal pattern for differential Manchester. Here we think about the next bit. So when we have bit 1 as the next bit, we have no inversion, and when we have bit 0 as the next bit, we have inversion. So if you remember Manchester encoding, how we do for that is, for bit 0 we used a pattern like this. So for differential Manchester, how I'm going to draw is, for this bit 0 I'm going to invert the signal like this. So here I have to invert the signal as this. So my next bit is bit 1, that means I have no transition, so I'm going to go along the line, and then here in the middle you should have to have a transition forward. What you have to remember for this Manchester encoding and differential Manchester is, in the middle of the signal you have a transition. So here even we do not invert the signal, in the middle we have a transition. So we are going to make a transition here. And for 0 bit, we have to invert the signal. So invert means we can't go along the line, we have to invert the signal. And then from the middle, we have to make a transition and then come here. And for the next 0 also, we have to invert the signal. Invert means like this. And for 1, when our next bit is 1, we have no inversion. That means we go along the line and make the transition. And the next bit is also 1. That means I have no inversion. No inversion means go along the line, and in the middle you have to make the transition. Right. So next bit is 1. That means no inversion, go along, and then in the middle you have to make the transition. And for bit 0, you should have to have an inversion, so I'm not going to go along the line. Instead, I'm going to go down and make the transition like this. So here you have to remember that in the middle of every bit you have a transition, and you have to think of the next bit all the time. And when your next bit is 1, no inversion, and when your next bit is 0, we have inversion.